What if I told you that Albert Einstein, the genius who changed the way we understand the universe, faced countless failures, ridicule, and personal struggles? Few people know the surprising moments of doubt, persistence, and resilience that defined his journey to becoming one of history's greatest minds. From his humble beginnings to the groundbreaking theory of relativity, join us as we gently unfold the inspiring story of a man whose ideas reshaped the world forever. Welcome to Legacy Narratives, where every story is a journey through history, wisdom, and memories worth remembering. The patent office in Bern, Switzerland, was a place of quiet bureaucracy, a world of stamped papers and meticulous records. In 1905, one of its third-class technical experts, a 26-year-old man with unruly hair and a playful glint in his eyes, was quietly revolutionizing the universe. Between evaluating patent applications for electromagnetic devices, Albert Einstein would hurriedly open his desk drawer, scribble down equations on scraps of paper, and then quickly hide his work whenever he heard footsteps. His superiors likely saw a competent, if somewhat distracted, young clerk. They could not have imagined that in that drawer, amid the mundane, the foundations of Newtonian physics were being gently, irreversibly, and brilliantly upended. This was the year of his annus mirabilis, his miracle year, when he published 4 papers that would change science forever. But the story of Albert Einstein is not merely one of sublime genius. It is a human story of curiosity, perseverance, and a deep, abiding belief in the harmony of nature. A journey of a mind that thought in pictures and dared to question everything. Albert Einstein was born on March 14, 1879, into a secular Jewish family in Ulm, Germany. His father, Hermann, was an optimistic and kind-hearted engineer and salesman. His mother, Pauline, a pragmatic and accomplished pianist who instilled in him a love for music that would become a lifelong solace. As a child, Albert was not the prodigy one might expect. He was late to talk, causing his parents some concern. A family legend recounts that at supper one night, he broke his long silence to complain, "The soup is too hot." When his surprised parents asked why he had never spoken before, he reportedly replied, "Because up to now everything was in order." His childhood was marked by deep curiosity and a resistance to rigid authority. The regimented militaristic style of his German school grated on him. He clashed with teachers who valued discipline over imagination. He later recalled that the spirit of learning and creative thought was lost in strict drilling, an experience that would forever shape his views on education. Yet, it was not all conflict. A pivotal moment came when he was 5 years old and his father showed him a pocket compass. The young Einstein was mesmerized. That the invisible force guiding the needle was acting through empty space seemed to him a miracle. This experience of wondering at the hidden mysteries of the world left an indelible impression. Another key influence was a poor medical student named Max Talmud, later Max Talmy, who joined the Einstein family for weekly dinners. Talmud introduced the 10-year-old Albert to a series of intellectual stimuli, popular science books, philosophical texts, and most importantly, a geometry textbook, which Albert devoured with uncontainable excitement, calling it his holy geometry book. He was soon teaching himself calculus. This self-directed learning, free from the constraints of formal school, was where his true mind began to flourish. At 16, he performed a thought experiment that would echo through his life's work. He tried to imagine what it would be like to ride alongside a beam of light. If he could travel at the speed of light, would the light wave appear frozen to him? This question, which seemed to contradict James Clerk Maxwell's laws of electromagnetism, planted the first seed of what would decades later become the theory of relativity. After finishing school in Switzerland, he had renounced his German citizenship to avoid military service. He graduated from the Zurich Polytechnic in 1900. He was a brilliant but impudent student, often skipping classes to study physics on his own terms. This alienated some of his professors, which left him struggling to find an academic post after graduation. After 2 years of temporary teaching jobs and near destitution, a friend helped him secure the now famous position at the Swiss Patent Office in Bern. It was, ironically, the perfect job. It provided a steady income to support his new wife, Mileva Maric, a fellow physicist and the only woman in his university class, and their young son, Hans Albert. More importantly, the undemanding nature of the work left his mind free to wander the cosmos. Then came 1905. In the span of a few months, he published 4 papers in the prestigious Annalen der Physik, each of which was a seismic shock to the world of physics. 1. On a heuristic viewpoint concerning the production and transformation of light. This paper proposed that light is composed of discrete packets of energy called quanta, later called photons. This bold idea, which helped explain the photoelectric effect, was a foundational stone of quantum mechanics, though Einstein himself would later become uneasy with the implications of a probabilistic universe. 2. On the motion of small particles, suspended in a stationary liquid, as required by the molecular kinetic theory of heat. This paper provided a theoretical explanation for Brownian motion, the random jittering of pollen grains in water, offering convincing proof of the existence of atoms and molecules, which were still debated concepts at the time. 3. On the electrodynamics of moving bodies. This was the paper that introduced the special theory of relativity. Einstein discarded the concepts of absolute space and absolute time. He proposed that the laws of physics are the same for all non-accelerating observers, and that the speed of light in a vacuum is constant, regardless of the observer's motion. From this deceptively simple premise flowed astonishing consequences: time dilation, moving clocks run slow; length contraction, moving objects shorten; and the equivalence of mass and energy. 4. Does the inertia of a body depend upon its energy content? A short follow-up paper that derived the most famous equation in history, E=mc2. This stated that mass and energy are two sides of the same coin, and that a tiny amount of mass could be converted into a staggering amount of energy. The physics community took notice. The patent clerk was invited into academia, holding professorships in Zurich, Prague, and finally, in 1914, at the University of Berlin. This move strained his marriage to Mileva, and they eventually divorced. In Berlin, he embarked on his magnum opus, extending his theory to account for gravity. For 10 years, he wrestled with the mathematics, often on the verge of despair. The breakthrough came when he realized that gravity is not a force pulling objects together, as Newton had said, but a warping of the very fabric of space and time, a four-dimensional space-time, caused by mass and energy. A planet orbits a star not because it is being pulled, but because it is following the curved geometry of space-time around the star, like a marble rolling around a funnel. In 1915, he presented his general theory of relativity. It made a bold prediction that light from a distant star would be bent by the sun's gravity. During a total solar eclipse in 1919, British astronomer Arthur Eddington led an expedition to measure this effect. When the results confirmed Einstein's prediction, he became an overnight global sensation. The London Times headline read, "Revolution in Science, New Theory of the Universe, Newtonian Ideas Overthrown." He was suddenly the world's first scientific superstar, a symbol of pure genius. But Einstein was more than a physicist. With fame came a platform, and he used it to speak on the social and political issues of his day. A lifelong pacifist, he was horrified by the nationalism and destruction of World War I. In the 1920s and 30s, he became a prominent advocate for disarmament and world government. As a Jew, he was a particular target of the rising Nazi Party in Germany. When Adolf Hitler came to power in 1933, Einstein was on a visiting professorship in the United States. He immediately renounced his German citizenship for the second and final time, never to return. The Nazis denounced his work as Jewish physics, burned his books, and put a price on his head. He settled at the Institute for Advanced Study in Princeton, New Jersey, where he would remain for the rest of his life. Princeton became a sanctuary. He was a familiar figure, walking its streets in rumpled clothes, his white mane flowing, often lost in thought. He continued his work, now in a decades-long, ultimately unsuccessful quest for a unified field theory, a single framework that could explain all the fundamental forces of the universe. The rise of Nazism, however, forced him to reconsider his absolute pacifism. In 1939, fearing that German scientists might be first to develop an atomic weapon, he was persuaded by Leo Szilard to sign a letter to President Franklin D. Roosevelt, urging the United States to begin research into nuclear fission. This letter initiated the Manhattan Project. Einstein, deemed a security risk due to his socialist leanings, played no part in the project. When the atomic bombs were dropped on Hiroshima and Nagasaki in 1945, he was devastated. "Had I known that the Germans would not succeed in developing an atomic bomb," he later said, "I would have done nothing." It became his greatest regret, and he spent his post-war years tirelessly advocating for nuclear disarmament and world peace, chairing the Emergency Committee of Atomic Scientists. His later years were a blend of scientific pursuit, gentle eccentricity, and heartfelt activism. He continued to challenge the orthodoxies of the new quantum theory he helped create, famously stating that God does not play dice with the universe. He was offered the presidency of Israel in 1952, which he humbly declined, saying he lacked the natural aptitude and experience. He became a vocal critic of McCarthyism and racial segregation in America, championing civil rights and calling racism America's worst disease. Albert Einstein died on April 18, 1955, in Princeton Hospital. His final hours were spent working on a speech for an Israeli independence event and scribbling equations on a bedside notepad. His remains were cremated and his ashes scattered at an undisclosed location in accordance with his wishes. But before his body was cremated, in a strange and perhaps fitting coda for a man who sought to understand the deepest secrets of the universe, the pathologist at Princeton Hospital, Thomas Harvey, performed an unauthorized autopsy and removed Einstein's brain, hoping science could one day uncover the source of his genius. The legacy of Albert Einstein is not confined to the equations that transformed our understanding of space, time, and the cosmos. It is a legacy of a certain spirit. It is the spirit of boundless curiosity, of questioning authority and received wisdom. It is the image of a gentle, humble man who saw the universe as a profound and beautiful mystery to be pondered, not just a set of problems to be solved. He showed us that imagination is more important than knowledge, for knowledge is limited, whereas imagination encircles the world. He was a scientist who never lost his sense of wonder, a genius who remained deeply human, and a pacifist who was forced to confront the terrifying power of his own ideas. His life stands as a timeless testament to the power of a single curious mind, to change not only how we see the world, but how we understand our very place within the magnificent, mysterious fabric of the universe.